example, then you guys form a team, then start the next page. I will give more information about the third and fourth page, what you guys need to do. Then I gave you the brief idea of the third step. You can start. Okay? Okay, so let's start. Basically the NoSQL data modeling is not complicated comparing to the relational database model or other DBMS model. So the reason is that the NoSQL database try to address the problem of the relational database in terms of the scalability, which means it should be because we have as we discussed a lot beginning of semester, we have the really big data. So that cannot be addressed by the relational databases. So to address that, we need to simplify the constraint. We need to simplify the schema. We need to make the simple the data model. And also we need to address the very complicated constraint like the normalization and so on. Then our idea of the NoSQL database, we make the simple model of the data, such as the key value. So then, mostly the NoSQL database model is focusing on the combining into the simple model. It's a denormalization or aggregation. So we are going to focus on the how to aggregate or how to denormalize the existing data model. And also, if we are dealing with the graph database, that fits to the graph data model, which is different from this one. So in this discussion, we will mostly focus on the how to aggregate, how to denormalize the data that fit to the mostly key value. Okay, so that is the idea of the NoSQL database, the model. I'm going to skip the very basic fundamental idea of the data modeling and the data that we discussed a lot before, including the advanced database design. Okay, but what is a data model? What is the idea of the data model? No matter what type, regardless of the type of data model, what is data model? Why do we need to model the data? Because computer, eventually we are going to use the computer research to manage, to handle, to curate, to search the data. However, unlike the human brain, the thinking process and inside the brain, we don't know exactly how the human being brain is working to store or to manage the data. It's working on, like the neuroscience, so it's the neuron or whatever, but still it's a kind of black box. But it is true, it is different from the computer. Computer use basically 0 or 1, such the electronic device. Eventually, we need to make the data fit to the such a computer data structure. Because of that, computer cannot understand just what we are saying, whether just the information. Instead, we should fit the information or data that to the computer data structure. That process is called the modeling. So for example, if we consider the data as a relation, kind of group of data is a relational modeling. If we consider the data as an object, so we have the collection of the object. Even this object is a superclass of this one. So like we can consider the object-oriented modeling. So if we regard the data as a kind of a stream of the network, it's a network modeling. So that is the idea of the modeling for the NoSQL database. The NoSQL database, such as a key value database, we need to make the data to the key value, such a data structure supported by the NoSQL database. So that is called the data and the database modeling. So I'm going to skip the introduction of the data and the data modeling that we discussed a lot in advanced database design, even the last class during the relational database thing. Okay, it's a requirement of that. So I emphasize on a lot. So this diagram. So this diagram is used for any kind of database project. It's not only the relational database model, but NoSQL database. While you are doing the third and the fourth step of your project, this part is for the functional analysis, your application. Always, our database serves for the application front end part. If you are using the database for the web server is this one. Then to support the application part, we need to design the database. Sometimes we don't need such a complicated database design. Instead, we can use just a file system like the traditional web application server. Web application server stores the data as a HTML file, not like this here. But if we are using relational database, that relational database serves for the such an application program. In your NoSQL database project, you need to also think about such a step. So basically, it consists of the two parts. It's the conceptual design and the physical level design. The conceptual level design means it's the designing the model, the data that fit to your database model. But it's before to create the database. Then after you create the conceptual level design, then finally you can create the database object like a table, or sometimes it's object, it's the database, so on. So keep in mind such a database step. I'm going to skip such a fundamental of the database model. So this is the evolution of the data model. So we have the different generations. Somebody uses the first generation, second generation, or so on, but it's not the big deal. So first, our database model starts from the 1950, 1960. At the time, as you learned in your advanced database design, we have used the hierarchical database or network database model. Network database model is not very popular nowadays. Even I never seen, frankly speaking, I never seen the network model, the database. But the hierarchical database is being used a lot, even the currently. So there are the hierarchical databases still very reliable and fast to access the data from the root and the next level and next level. So that is a hierarchical database. It's traditional. Then from the after the KF code proposed the relational database model, then the people actually EI modeling is after relational database model. So first, Dr. E.F. Code and the group proposed the relational database model idea, proposed the relational concept. Then that is for the database model. Okay, to eventually implement the DBMS. like the System R project, DB2, Oracle, and so on. But they realized that the traditional way of the data model, like the hierarchical data model or the network data model, is not feasible to the relational database. So they need to find something different to approach to model the data. That is the conceptual level design, and that is entity relationship model, actually. So mostly the group of the scholar and the professor in the Stanford University and the Berkeley, so mostly Stanford. One of them is actually my supervisor in my PhD, Professor Dr. Elmersary, who authored our textbook for the advanced database design. And right now, the conference and the group of the people they are not very popular because ER modeling is almost done and it's being used in the real application. But 1970 and 80, especially the 90, it was really the popular the group of the conference. People to talk about this one. This is what we currently use in our relational database model. Then, after this one, with the help of the internet and so on, our data, the structure is varied. It's more flexible, like the XML or the something document, markup language, and so on, and also object-oriented concept. So it's a more semantic level. So that is object-oriented model and extended relational model, or DBMS, and also XML. Like it was actually a hot issue when I was a student, early 2000. So can the XML? The XML is the extended markup language. Can XML replace the relational database or not? Because after 2000, what happened? It's a .com, which means everybody would like to use the computer resources, especially based on the internet, and they use a lot of relational database. Then the Oracle, for example, it is the first company in software industry. So everybody uses huge the money capital they got. So in academia, they think about what about the future, next version of the next step, next generation of the relational database. And they thought XML maybe the next, the future of the relational database. Then somebody would like to use the XML for the query, like the X query. Nowadays, not many application people are using the X query, but there was the X query and the query optimization. So which means we store the data in the XML format. Then the retrieve. Then to do that, we need to query optimization, query processing, and there are a lot of such things. But that's only the few years. Then after that, somebody believed the ontology can replace. Ontology focuses on the more semantic level, the knowledge. Instead of the data itself, the data structure itself, the more like the knowledge base, the database can replace the existing relational database, but which didn't happen. So still the relational database is the winner. Then, but recently, due to the power of big data, the problem of the big data, NoSQL database is cannot overcome the replace the relational database yet. But anyway, it is true. The NoSQL database is getting bigger and bigger. So this is kind of the history of the data model. So NoSQL database model, so mostly the combined due to the nature of the big data and the big data processing, so aggregation or denormalization. We are going to see how can we do that. That we already discussed about that. So basic idea of the NoSQL data-based modeling. Data modeling is a denormalization and aggregate, and application side the join. Meaning is combine. Okay? We are going to compare into one simple data structure. What is the denormalization? In your the advanced database design. What is the normalization? Remove redundant data. What if we have redundant information? It's very hard. It takes a time to find the data. So if we remove the redundant data, like the primary key, 1, 2, 3, 4, 5, that is the fast. We can use the index, even we can use the binary search to search the data. However, if we have the redundant information, then always we need to check every data and the full table scan, which will take a longer time. So our goal of the relational database model, avoid any redundant. How can we do that? Through the following normalization process. It's kind of standardization. Basically, get rid of any redundancy, like the attribute level and the key level and something other level, then we will remove such a thing. It's good. The problem takes the time. Think about the one data source here, another student are here, the faculty are the next group, and staff are the another group, course information are another. So when we collect the student taking the class, we need to access the two rooms. Every time check here, check here. So it will take a longer time when we join. Okay, join looks good, but actually the join require a lot of research. So in terms of performance, actually join is really the bad operation. It's a very expensive operation. So even in the relational database model, if we want better performance, we can denormalize, which means combine into one. Instead of two rooms, even though we sacrifice such a redundancy, allow the redundancy, but we pursue the performance by combining, so like the student and faculty are in one room. It's messed up, but it will be easy to match. So that is the idea of the denormalization. So denormalization is one of the approach to make the mostly the data model that we are going to discuss today is focusing on the key value and the document database or the big table. So we can denormalize from the existing data source, like my data is the company database. So for the company database, we do the ER modeling, then eventually we have the relational schema diagram, something like that, by following normalization. But in our NoSQL database, we try to combining the related information by applying the denormalization. So, however, still denormalization has a key. Even though we combine, we mostly have the composite key. That is a denormalization problem, because we cannot keep the purity of the data. We need to allow something to duplicate redundant information. Aggregate is similar as the denormalization. Denormalization usually when we have the two data like this is a foreign key DNO is a D number, and this is a SSN, like that. There is the employee, and this is a department. If we denormalize, it will be like the employee ID, the SSN, and the DNO as the primary key add all attributes. We can denormalize into this one. So this is a denormalization. But aggregate is quite similar, but slightly different. Let's take a look at the example of the aggregate. So we have the product, okay, but there are different types of product, maybe. So we can normalize the book, album, and gene, and so on. Because book has the different attribute. Then the album has the artist title. Even the artist title, the album has number of track. And the gene has the model and length and the width. If you think about the super and subclasses, okay, in the ER model. Then what we want to do is instead of combining of this, we can create one table, another table, another table, another table, also another table for this one. This is normalization in the relational model. However, if we implement this one with the big data, like the NoSQL database, what happens? We need to combine every time to access the price of the older product separately. Or even we need to join. That join causes a huge performance issue in the big data. So instead, why don't we aggregate? Aggregate is different from the normalization. Instead, aggregate the similar entity into the one product, but each product can have their own attribute, like as a detail. If you see the detail, it's the author for the book and the title and publication date for the book. However, in case of the gene has a model and name and the length and the width. And what about the album? Even album has artist title and track. Track has their track number 1, track number 2, track number 3. This is what? JSON format. So we can model into the by aggregating such a similar product, number of product into one product, but that's the benefit of that like the schema list. There's no specific schema of this. Depending on the product, it will have the different details of it. Okay? So that is called the aggregation. So we can use the aggregation by combining number of them. Okay? So that is aggregation. So we can do the similar thing for the company database. So we discussed a lot in the ER modeling, and when we convert into the relational schema diagram, we can say there are different options. So, but if we are using the such aggregation, so we can create the employee. Then this one has the common name and the SSN, DOB, and address, and the job type. For the job type, we have the different description of the job type. That is in case of secretary has this information, and technician has a different information, and so on. That's the aggregation of that. However, we can, for example, in this case, if we combine all the details of the information if we need to aggregate, it will be much more complicated. So sometimes we cannot aggregate. We should not aggregate. Instead, we can use the application side join. Application side join means, so for example, the job type is 1 or 2 or 3, and 1 is the secretary, and 2 is the technician, and 3 is the engineer type. This is a table. Then we can join. In case of the relational database model, we can join with this one. This will be employee has a job type, and the one, in case of 1, is the secretary, and so on. We can use join. In the case of for the aggregation, so it will be combined into this. In case we cannot aggregate, then we will combine this information during the processing in your MapReduce program. Mostly when the join the table is simple. In case join table is simple, so when we are doing the mapper, during the mapper, we select the key and value while we are processing key and value. In case 1 is a secretary, and case 2 and technician, and so on. So instead of join or aggregation, and during the model, we can use the application side join. So application side join is when you are considering such the small table. Mostly it's a small table, sometimes it's code table. this can be joined during the processing. This is application side join. So the NoSQL modeling technique include this one. I'm going to explain the one by one. So for example, in case of the entity, we have the user account, address, and the user profile. Okay, so this is the normalization processor. If we need to build something business entity transaction, we need to access this one and this one and this one. But most of the time, if any transaction require to access account, address, and the profile same time, including insert the new data, update the new data, and something modify. So these three are working together. Then we will consider as a group, so atomic group. So this will not be managed separately. That requires a lot of the complexity, huge complexity. We need to log this table and update. Instead, we will consider as the aggregated group of data. That is called the atomic aggregation. So in case we need to keep something consistency of data for those three and number of entity, we can consider the atomic aggregation. Many of the time, when we create the big data and with the NoSQL database, we have at the timestamp 2019 and 18, the October, the 11, and timestamp 18, the 32, and something the information. So this is raw data. And next, when we manage this kind of the data in our NoSQL database, in case of key value, we need to find which one is key. At this, the date and timestamp is the key. Then the value is something the code value, or the source IP, or destination IP, something like that. This one is okay as a key, but to manipulate, to search, it takes time. Instead, why don't we generate the sequence number for the key? Like if you remember the relational modeling, so we can create the sequence unique number. It's called the surrogate key. Surrogate key is artificial key in case when primary key is composite and is complicated. You can use such a composite primary key, but it will take a longer time to store, to manage on the memory. Instead, we can create a surrogate key. It's the same idea when we model the NoSQL database. Instead of such a composite, the key, we will assign the number. That is the enumerable. The key enumerable key, as you know, it can be comparable. So we can use such the number for the comparison. Then we can check the search such a data. I'm going to skip this dimensionality reduction. This one used for something the old-fashioned data type, like the two-dimensional data. It's called the field curve, because it is not easy or even impossible to represent the two-dimensional or multi-dimensional data into the simple one-dimensional data. So we can actually convert the multi-dimensional data into this one, but this is not practically used a lot. Actually, this technique used for multimedia data processing, multimedia database long time ago, when we cannot handle the video data, image data directly. It's like, for example, image. So no way to directly store the two-dimensional data into, for example, relational database. So we convert the two-dimensional data into one dimension. It's the dimensionality reduction, like the geohash. But nowadays it's not practically used, so I'm going to skip this part. Then sometimes, since in general, nowadays most of the NoSQL databases support the external data structure for indexing. Even today's presentation, we have seen some of the NoSQL database support the indexing, the data structure for efficient query. But during the modeling, we can have the index, the data structure, indexed model. It's a modeling itself, it will be indexed. For example, in this case, this is our the user information data, and the user ID and their information, and the user ID, their information. But if we know about the application that usually search by the city name, which users are in the specific, then we can actually model by following the application requirement. It's indexed. The data structure, like the city name, San Francisco has a number of user ID, and the New York has a number of user ID. Seattle has a number of user ID. This one is very similar as inverted index. So we will see the inverted index later somewhere. Yeah, inverted search, using the inverted index. What is an inverted index? Traditional approach of index is we are going to sort the data, right? So if we have the one, this is ID and name, ID 1, 2, 3, sort the data by ID and their name. So this will be index. This is the conventional way of the indexing. However, what if data item is document, JSON file, just a document, HTML file. This HTML file has something University of Bridgeport and the School of Engineering and another HTML file. This one has a Bridgeport and C and so on. The conventional way of indexing is we try to order this document by something keyword, okay? Like this way. This is a conventional way. Then this is not like the group of attributes, unlike the relational model. This data type is the document. So if we reorder this one by the certain keyword, even we cannot get the benefit of ordered set. Okay, fully. Instead, what we want to do is the inverted index. Why don't we first collect the index key item that we are going to use? For example, the Bridgeport. And Bridgeport is in the document number 1. The document number 1, document number 2. And the city is in the document number 2. And the university is in the document number 1. Then when this keyword is used for search, then we don't have to retrieve the entire document, just return this result. So this is called the inverted index. So inverted index is the first the approach using the internet search engine. So internet search engine uses as inverted index. This is the same the idea of the inverted index. So when we model the data of the NoSQL database, so we will use such the index item for that is called the index table. Composite key index is what if we have the keyword, combine the keyword to search the data, like not only just a CD name, it has a state name and CD name, and this is a zip code. So we can actually use the composite. So not only just one level of indexing, the multi-level indexing by combining several attributes. So for example, the first layer is the state. So if we search by the state, we can do the range search. Okay, so from California is California here to here. But if the search is by the city, like the San Francisco in California, then this range will be return the search of that. Okay, so this is a extension of the such an indexed table by using the composite key. Okay, then we can further use of the such a aggregation. So this one is a composite key. Then this composite key has the, for example, certain user, in this case, user ID and the event ID and the site. This the website has such an event. And by combining the specific user, the frame for user ID. Yes, this is the same user, so we can have the document modeled to the document database by aggregate. So we have seen the aggregation before. So it's a full user ID. We have a number of the site for the event, number of event. So this is the extension of the using composite key for aggregation. So then we can have something document the data structure. So inverted search, I already mentioned about the inverted search for the inverted index. It's the same idea. So if we know such a keyword, so we can order by the keyword, in this case category, and this one is a CD and CD name, and this is a site, this is a user ID. So we can eventually make such a indexed document. And more the modeling for the NoSQL database. Alright, we have such a tree, like the data structure. Like we start from, this is I think the web pages. So blog has a number of contents. For each content, it has a number of comments. That comment from the certain number of user, and there is a reply, and so on. It's a hierarchical structure. This hierarchical structure can be aggregated to the document like this. Comment will be by a number of the user, and each user has the number of reply inside. So we can aggregate for the tree structure. Adjacency list will be used for the graph, so to represent the A, B, C, like this. This is the node number. We have the 5 number of node, and this is the edge. Edge represents the relationship between the two nodes. So to represent this data structure into the NoSQL database, including the graph database, they use the adjacency graph. The adjacency, the metric, represented by number of nodes and also number of nodes. In this case, A, B, C, D, E, and A, B, C, D, E. Then A is just the diagonal is the same node, so we can put the 1. If A is connected to the B, it's 1. A connected to the C, 1. And A does not connect to D any, it's a 0, 0. So 1, 1, 0, 0. And B, so connected to A and so B and C. So 0, 0 and 1, 0, 0. For the C, it connected A, B, C, D, E, all of them and all of them. And for the D, represent the graph structure into two-dimensional matrix. If you have the directional edge, like for example Facebook is follow. In case of Twitter, you can just follow. You don't have to get the permission from the user. So follower will not be symmetric. Okay, it's one direction. But the Facebook is you need to get the permission from the other. The friendship is the symmetric. Also, if you are using the certain measurement of the relationship, like the number of posts, okay, number of the comment for the specific user, it is not just a 0 or 1. You can use such a measurement of the relationship. Level, degree of the, not degree, is a measurement of the relationship. So we can use such a adjacency graph, the list adjacency list, to represent the graph structure. I'm going to skip the materialize the path, which is not practically used a lot. Nested set. The nested set is so from the hierarchical, okay, hierarchical structure. It represents something. So project to the one dimension because it's a hierarchy. So from the here to here, that covers the certain level of the data structure. This is called the nested set. So for example, in this level, it's a home level. It covers the entire, okay, the information about under the home. But under the home, there are several levels. There's some category, like this is the kid. This is for bath. Then that will cover this one. For the kids, it's the school and so on. So we can represent the model into the one-dimensional level, which is the nested set. Okay. Then another approach for such a nested set is the nested document flattening. Flattening means is to make the simple, the one-dimensional data. For example, under the name of the student, we have the math, it's excellent, and poetry poor, and so on. It can be represented by the one document. So it's a flattening. So instead of the different category of the evaluation or the entity, we will combine. It's also the aggregation. At that time, which one will be aggregated, you can consider the application part. As I focused on the beginning, always such a modeling will be based on your application analysis. For example, in this case, mostly the search by the skill and their level. At the time, you can combine the skill and the level into one. It's depending on the different query. So we need to consider the different types of query. It's similar. For the graph processing, so I think this time I select the couple of the graph database, the NoSQL database. So graph. Mostly the dominant benefit of the graph data structure, it can represent the relationship. It's a neighborhood, which cannot be represented by the other NoSQL database model. So that can be represented by something adjacency or the relationship, and so that can be the model. This is the relational database style, but it can be represented by the graph data structure more the relationship between or among them. Okay. So this is the typical modeling process using the NoSQL database. As you can see, mostly it's much simpler than the relational database model to pursue the performance as well as the characteristic of the NoSQL database, which means that it's much more flexible in terms of a schema, and to support that, we'd like to aggregate or denormalize and make the document the data structure using like the JSON format. Also, eventually, the document, the graph database also can be modeled into the data structure using the adjacency. Most of the graph database uses such a adjacency metric to represent the relationship. Okay, so for the next step of the project, you are going to search your data, then the model based on this idea. Okay, the how many data source, the table, sometimes it's called the table, sometimes it's called the object, sometimes it's called the number of node. So you need to model. Then based on that model, you need to create your database and insert your data. Then you guys need to propose the application part. So web application or the performance testing. So any types of application are acceptable. So, but you guys need to design considering the characteristic of your NoSQL database. It can be search, it can be the performance testing, it can be the web application. It's any kind of application. Then implement using provided the API, programming API. You guys need to implement. Then during the presentation for the final step, you need to demonstrate and the system and present. Okay. Any questions? Okay, thanks so much. Before you leave, if you already designed your team, please let me know. I can assign your team member to the existing group. Okay, thank you.